Can everybody see the elevation up there? Yeah. Now watch what happens to the discharge elevation as the suction elevation goes up. So I'm going to add water. Are we pumping? No. What's happening? Is it rising? Yeah. So as the suction elevation rises, the discharge elevation rises. That is your proof that we need a suction and a discharge gauge on the pump. The pump is pumping differential head. So the pump takes the liquid at this elevation and raises it to here. If that happens, that happens. If that happens, that happens. If that happens, that happens. This will be a constant based on the speed of the impeller, the RPM, and the diameter of the impeller. And that's why we looked at those factors earlier today. So because the speed is fixed, because the diameter is fixed, the pump's head is mostly fixed. At shutoff head, it is fixed. At X flow, it is fixed. At Y flow, it is fixed. And as the suction head rises, the discharge head rises. As the suction head drops, the discharge head drops. So we just now lowered the suction head. So go back up to he ought to be able to control the discharge head relatively easy because the suction elevation also went down. All right, now there you go. The discharge head is right there just above his fingers, just above his hand. Can everybody see that? Now once again, watch it here. Don't watch me, watch up there. Is it rising? People, that is your proof. You need a suction pressure gauge and a discharge pressure gauge, and we need to know the differential. You're going to be surprised when you go back to work. You're going to find many of your pumps don't have suction gauges. Then the only thing I can say is, how can so many smart people get it so wrong? You're chasing vibrations and you don't have gauges on the pump. Something is really wrong with the way that we're doing our analysis these days. How do you govern the speed of a car? What are you going to do with the steering wheel? What are you going to do with the accelerator pedal? What are you going to do with the brake pedal? Now, I can govern a pump as the operator. I can govern the flow by adjusting the elevation differential. As the elevation differential goes down, flow goes up. As the elevation differential rises, flow goes down. Right now, he's at 0 flow. Now, hold that and go back into the bucket here and give me drops. Like you're the operator and I just want to see a little tick, tick, tick. Okay. Give me now twice as much flow as you have now. All right. Give me half of full flow. Come down right about here. All right. Now give me full flow. Now give me 0 flow. There you go. All right, now notice he's not pinching on a valve. He's not doing anything but governing the elevation differential. That is the upper elevation, and the level of water in this bucket is the lower elevation. So by governing the elevation differential, he can control his pump. Does everybody understand that? All right, now for the moment.